Okay, I'm going to begin in the middle of the, or toward the end of this. Don Saba, speaking for myself. I'm going to begin toward the end of this because I think it would be easier to do this.
Does the screen that's in front of you down on the table show to your left?
Oh, no, it does not.
It's not. Oh.
That's not. There you go. But I want to make sure I can work this thing here. I need to, oh, here we go.
Which is the easiest?
What's that? How do I make it go forward?
Don't forget about this one. I'll just use this one.
Just use this one? Will this be able to point out
You see
things?
it? Okay.
Will
If you want to do that, do this.
I'll use that then. Okay. Okay. All right. I want to start out talking about this chart here. In fact, I'm going to back this up to the. Wait a minute. What's going on here? That's the chart I want to show. I want to start out with. Wait a minute. There. Okay, I want to start out talking about this chart here. And this is the chart that Dr. Smith showed you in the past, and he alluded to this same chart earlier today. And this chart is intended to show, that the blood lead in condors approaches the, this chart intends to show that the isotopic composition of the blood lead of condors approaches that of ammunition. That's the intent of this. And on the left, you see these green circles here. Those are condors' blood isotopic ratios from captivity, where they're on a very stringent diet that's very well controlled. Over here on the far right, you see a, let me see if I can show you what it says. Okay, over here on the far right, you see it says ammunition here. And that is an error here. What Dr. Smith has put here is the isotopic ratios of just Winchester and Remington ammunition. That is not all the ammunition that's available in Condor country. I did extensive research on this. On 2 occasions, I provided it to the Commission in very extensive detail. My results are this regarding the isotopic ratios of lead ammunition. 1, the isotopic ratios of lead ammunition are very, very broad, over a wide range. How broad? Let me indicate that on the next slide. What's going on here?
Oh, Steve.
No, it's not. There are several after this. Here, let's try that. No. Are we going backwards? Okay, okay. No, we need to have, see, this is not showing up. I need to have my number 2 slide show full screen. That's it right there. Okay, can we get that one go full screen? Because I need to point something out about it. That's it. You've got it. Okay. What I've done on this slide here is on the right, you see that vertical green bar on the far right. That vertical green bar extends from the top of the slide to the bottom of the slide. The data on the isotopic ratios of ammunition available to hunters in Condor country. Isotopic ratios range from the top of the slide to the bottom of the slide and even about a foot below that projector. Okay. That's the isotopic ratio range that you will find in Condor country. I found over 106 gun stores that sell 35 brands of ammunition other than Winchester and Remington ammunition. Dr. Smith's study only shows Winchester and Remington ammunition. Now, the relevance of this, okay? If you look here at this slide here where you see the green round circles here, those are the Condor isotopic ratios from captivity. And then, as you see those yellow triangles there, just to the right of that, those are the blood-lead isotope ratios of condors in the area of under 20 micrograms per deciliter of blood lead concentration. And you notice that they broaden out. They broaden out from the tight green group there to a much wider group. And those wider groups, under 20 micrograms per deciliter, or 200 on this chart, those are approximating the isotopic ratios of lead in the environment, which is that red bar on the left. That huge red bar shows a broad range of isotopic ratios of lead in the environment. Okay, so what you're seeing is when you release those condors into the wild, then you're seeing the isotopic ratios start to spread out to reflect the isotopic ratios of the environment. Now, the trick is, what's happening above 20 micrograms per deciliter? Look what's happening here. Those condors, those yellow triangles, represent the isotopic ratios of the blood lead from condors. What it seems to be doing is approaching around 0.81 isotopic ratio. Now, how can that be? You've got condors released in the wild. You've got ammunition that ranges from the top of that chart to the bottom of that chart, that green bar there. You would expect, if the condors were being poisoned by carcasses contaminated with lead bullet fragments, that the blood isotopic ratios would reflect the isotopic ratios of the lead from the bullets. That's not what we see here. Let me show you. Let me see if I can pull this sequence off without screwing it up. The next slide will show you what you would expect to see if the condors were indeed eating carcasses from ammunition, and it would reflect the isotopic ratios of the ammunition. All right, we're going to get this right. Oh, that's it right there. That's it right there. You see that? Those squares of yellow. That is what the isotopic ratios of the lead in the blood of condors should look like if those condors are eating carcasses laced with bullet fragments from ammunition. See how it goes from the top of the chart to the bottom? It shows all the isotopic ratios as a reflection of that green bar on the right. So what's going on here? What it appears, take a look at this, see if we can, I'm going to be brave here and try to pull these, shoot them back and forth here. Look at this. Okay, this works. This is the data from Dr. Smith's paper. That's the data where you should see a dispersal of lead isotopic ratios over the broad range. But look what you really see in Dr. Smith's data. You see that. See how those yellow triangles are approaching 0.81. But if you were getting ammunition, if you were getting lead contamination from ammunition, you should see that.
Okay. Dr. Saba, we take your point. You're over your time. Could you summarize?
Yes. So my conclusion with this is evidence that you are not getting contamination from ammunition.
Okay.
You see what you should see. But the conclusion is that you should be, you see how these triangles approach 0.81. My conclusion is that you're really seeing contamination by some source of lead in the environment that has isotopic ratios in the 0.81 range, and not that broad range from ammunition. I'm suggesting a single point source of some other source than ammunition.
Thank you.
Thank you for indulging.
Are there any questions, Dr. Saba? I have one. Do you happen to be aware of any other source of lead in the environment that has that 0.81 signature?
No, I do not. I don't.
That'll be an interesting question to ask.
Well, that's my question too. It's something I was offering here. The data seems to suggest this. Can we look for it?
We take your point.
Can we look for it?
And I'll be asking Dr. Smith why he picked Remington and Winchester, but we'll get to that in a minute.
May I just say that this document here has all this PowerPoint in it.
We got it.
Yeah.
Thank you, sir.
Thank you very much.
Thank you for your efforts. Next.